Amortized loans are loans in which the borrower repays the interest and part of the principal every period. So the borrower does not have to repay the entire principal at one go, but rather breaks it up over periods. So amortized loans are wonderful things for consumers. Say I have seen this high-rise condo which I really like, and also I've seen this new car which I also really like, and I start thinking that I would like to have both of them. So I look at the money I have. Not certainly I don't have enough cash. Well, I check my bank account. No, I can't buy the condo and the car with the money I have in my bank account and my wallet. So what I do instead is I look at my monthly income statement. Much better. So I can actually now take an amortized loan and using my monthly income pay back the loan over time. So we start with a very simple example of an amortized loan. The borrower has received $10,000 today. The interest rate is 8%, and the loan is to pay back in 3 equal installments of $3,880 and 34 cents. So how does this work? We are going to see how this monthly payments of we are going to see how these 3 equal payments of 3,880 is going to pay back the loan of 10,000 at an 8% rate of return. The 8% rate of return is for whoever lent the money, they get the rate of return. So for this loan, the starting principal is 10,000. So for the first period, finding the interest is very simple. You simply multiply 10,000 by the rate of interest, which is 8%, to get 800. So that's your interest for the first period. The borrower, however, has paid 3,880 and 34 cents. So part of it goes to pay the interest and the remaining goes to pay off the principal. So the amount of principal reduction would be the total payment minus the part which is interest. So that's 800, or that would be $3,080.34. So in the first period, of the 3,880.34 which was paid, 800 is interest payment and the remaining reduces the principal. So for the second period, the starting principal will be the ending principal for the first period, and the ending principal for the first period will be 10,000 minus the principal reduction of 3,080.34, or that will be 6,919.66. So for the second period, the starting principal will be the ending principal of the first year, so that will be 6,919.66, and interest rate for the second period is also 8%. So interest will be calculated on the starting principal. You multiply this by 8%, and what you get is 553.58. So again, the principal reduction you will find by seeing what the total payment was, and from that subtracting the amount of interest which was due. So the total payment was 3,880.34. Remember, this is a kind of annuity kind of repayment where the borrower is repaying a fixed constant amount of this every period for 3 periods. So minus the interest payment would be 553.58, and that is going to be the principal reduction for the second period, and that is going to be 3,326.76. So now from the starting principal you take out the principal reduction, and that will give you the ending principal at the end of the second period, which is going to be $3,592.90. So this you're getting by subtracting this from this. This was the starting principal for the second period. This is the amount of principal reduction. So the ending principal will be the starting principal minus principal reduction. Now the ending principal for the second period will be the starting principal for the third period. And on this starting principal, the interest for the third period will be calculated. So that will be this multiplied by 8%. The interest rate remains at 8% for all the 3 periods. That is what the loan was given at those terms, that the borrower will have to pay 8% on the outstanding principal as long as there is any outstanding principal. So the interest would be 287.44. That is, multiply this by 8% gives you 287.44. Now the principal reduction is going to be again 3,880.34 minus the interest, which is 287.44. Now pause a moment. If these payments actually pay off the loan, then what must we have at the end of the third period? The principal must have reduced to 0. That is what is meant by saying that these 3 payments of 3,880.34 repay the entire loan. So this is actually 80.34. 3880.34 minus 287.44. If you do that, what you get is 3,592.90, which is the same as the starting principal for the third year. So at the end of the third year, loan is wiped out. The card is now all mine. So of course, here you're given the periodic repayment which pays off the loan. You may have to calculate that. And what we are going to see is that if you want to calculate it, you can of course try trial and error, and you can spend many years doing that, but it's quite simple if you actually use the annuity formula. So what is the present value of an annuity with yearly payments of 3,880.34 over 3 years? Using the annuity formula, we will have 3,880.34 divided by the rate of discount, which here is 8%. That's 0.08 into 1 minus 1 upon 1 plus r to the power 3. So that will be 1.08 to the power 3. So this amount is 2.577097. multiplied by 3880.34. So this amount is this multiplied by 3880.34, and you get 10,000. Once again, whether you're discounting, which is what the annuity formula does, or whether you're from first principles moving forward and seeing how much interest there is every period and how much is being paid off, the answer you get is the same, because whether you move forward at a rate of 1.08 or you move back by dividing by 1.08, you're going to have the same answer. So there is only one exchange rate across time here, and that exchange rate is 1.08 for moving forward by one period, or also 1.08 by dividing when you move back one period. So whether you analyze this problem like we did in the previous slide, where we were looking at what the interest payment every period was, and then seeing what the principal reduction was, and seeing that these payments actually paid off the $10,000 loan, or in this slide what we are saying is, okay, suppose I have these three payments and the rate of discount is 8%, so whoever is giving me the loan, what is the value of these three payments to that person? And the value from the annuity formula turns out to be 10,000, which is the amount which I will be loaned. Now, of course, by using the annuity formula, you don't have to anymore rely on me to give you what the periodic payment will be. You can calculate it, because you can say that, okay, I know that the loan was 10,000. I don't know what the periodic payment is, so let's say that's C, and let's say the rate of interest was 8%, so it will be C divided by 0.08 into 1 minus 1.08 to the power 3, and this amount, you know, is 2.577097. So you take it on this side, so that is basically you divide 10,000 by this amount, and the answer you'll get would be 3,880.34. So if somebody told you that you have a $10,000 loan to be repaid over 3 periods, the interest rate per period is 8%, what would be the periodic payment? You can approach the problem in this manner and find that the periodic payment would be 3,880.34. Now we have a 15-year loan, a mortgage for $150,000. The interest rate is 0.75% monthly, and the monthly repayments are 1521.40. The question is that after 2 months, the borrower wishes to prepay, get out of the mortgage. So what is the amount which the borrower has to pay if the first 2-month payments have been made? So on our timeline, $150,000 has been borrowed. The first payment of 1521.40 has been made. The second payment of 1521.40 has been made. And at this point, in addition to the second payment, the borrower wishes to pay off the remaining loan, get out of the remaining loan. So the question is, how much will the borrower have to pay? Well, we start out with the beginning principal of 150. The interest on this beginning principal will be 150,000 multiplied by 0.75%, which is 0.0075, or that is 1,125. The payment was 1521.40 minus 1,125 would equal 396.40. So this is the amount of principal reduction, that is the amount paid minus the interest on the principal, and you take out this 396.40 from the beginning principal of 150,000. So you're going to get 150,000 minus 396.40, and you get the ending principal to be 149,603.60. So the beginning principal for the second month is 149,603.60, and you multiply that by 0.75% to get the interest. So 149,603.60 into 0.0075 gives you the interest to be 1,122 and 3 cents. So if this is the amount of interest and the repayment is 1521.40, then you take out the interest from the total repayment to get the principal reduction. So you have 1521.40 minus 1122.03 equal to 399.37 cents. You take out this principal reduction from the beginning principal for the second month, which was 149,603.60 minus 399 and 37 cents, gives you the ending principal to be 149,204 and 23 cents. So this is the amount left to be repaid after the two payments have been made. So if you're repaying the rest of the loan at this point, then you have to pay 149,204.23. The question is, can we think of this question in another way? And yes, we can. We can think of it in terms of discounting rather than doing it from first principles like this and moving forward every period. The amount of money to be repaid here is essentially equal to the value of the remaining repayments. What we have in this loan is that the 150,000 equals the payments of 1521.40 brought back each period at the rate of 0.75%, which 1 plus R would be 1.0075. So you bring back money every period by dividing by 1.0075. Now, when you repay this loan at the second period, what you're doing is that you're saying, I do not wish to make the remaining 178 payments from third, fourth, and so on periods, and each payment is 1521.40. So the borrower, when repaying, is essentially wanting to get out of the third, fourth, and so on remaining repayments. So the bank will say, well, you want to get out of these repayments, then pay us the present value of these repayments. So what is the value of these repayments at this point in time? Well, it is an annuity of 1521.40 divided by 0.0075 to get the value of the annuity. So it's an annuity of 1521.40 for 178 periods. So it will be 1 minus 1.0075 to the power 178. So this is the value of the remaining 178 payments at this point in time. And if you compute this value, it turns out to be 149,204.24, which is the same answer you got when you moved ahead by 2 periods. There's only a 1 cent difference, which is due to rounding error. So you see that whether you think of the loan as 150,000 invested, growing at 0.75% every month, and then you find out the remaining principal, or alternatively you think of the remaining principal as the value at time 2 of the remaining 178 payments, they shall both give you the same answer because they are both correct logically. When you move money ahead in time by a factor of 1.0075, or you move it back in time by a factor of 1.0075. So you can approach it either way. Rate of growth or rate of discount, same answer. Here we have a 30-year mortgage. The amount is $200,000. The interest rate is 0.5% monthly. And the first question is, what should be your monthly payments? If we draw the timeline, and if this is today, then there are payments C made every period till the last period, which is 360. So the amount of money that is lent today, which is 200,000, equals the present value of all these monthly payments of amount C. Now these monthly payments are discounted at 0.5% monthly. So the rate at which you move these back is 1.005. So the value of this annuity should equal 200,000, or the equation we solved to find the monthly payments would be 200,000 equal to C divided by 0.005 1 minus 1 upon 1.005 to the power 360, there being 360 months in a 30-year mortgage. So you solve this, you can solve this amount and then take it on this side and multiply it by 200,000, and what you get is C equal to 1,199 and 10 cents. So a payment of 1,199 and 10 cents monthly pays off a $200,000 mortgage. Alternatively, you can think of it as the discounted value of 1,199 monthly for 360 months equals $200,000 today. The second part of the question asks that if prepayment is done after 60 months, then how much of the principal remains to be paid? So what has to be the prepayment? So what we have is a situation where at the 60th month, the borrower wishes to get out of the remaining payments of 1,199.10. So there are monthly payments of 1,199 and 10 cents. So the borrower wishes to get out of these remaining payments. So how much does the borrower have to pay at time 60? So that is the second question. Now the amount to be paid by the borrower will be the discounted value of the remaining 300 monthly payments of amount 1,199 each. So we will have repayment equal to 1,199 and 10 cents divided by the discount rate 0.005 into 1 minus 1 upon 1.005 to the power 300. And this repayment amount turns out to be, if you compute this, 186,108 and 71 cents. So to go over this one more time, what we have is the borrower wishing to pay off the remaining loan at time 60. So the amount to be paid is the present value of the remaining 300 monthly payments of 1,199 and 10 cents each. So that would be found by the annuity formula, where you have the monthly payments to be 1,199 and 10 cents, the discount rate to be 0.5%, and the number of periods to be 300. There are 300 periods left when the borrower wishes to prepay. So this amount turns out to be 186,108, and that is the amount which has to be paid on the 60th period, in addition to the usual monthly payment of 1,199 and 10 cents at the 60th period. Don't forget that there is a payment of 1,199 and 10 cents at the 60th period, this amount to be paid for prepaying the loan is in addition to this amount of 1,199 and 10 cents.